everybody. How's it going? I hope you're doing well. I wanted to show you a couple of very important things about angles in a circle. So what you're looking at here on the GeoGebra app is a circle, and it has 4 angles inscribed in it. Actually, there's a whole bunch of angles in there, but I would like you to focus on just the colored ones. For example, angle MBP, that purple angle going over there, or angle MCP, or the pink one, or the orange one, or the blue one, all right? All 4 of those angles are the ones that I would like you to focus on here for a few minutes. Now, each one of those angles has a couple of very important things in common. You may have already noticed them, but I'm going to explain them anyway. First off, all 4 of those angles are called inscribed angles. I-N-S-C-R-I-B-E-D, inscribed angles. An inscribed angle in a circle is an angle that has its vertex right on the circle. All right, so they're all 4 inscribed angles. Next thing is that they all mark off the same piece of the circle. That's what I've got labeled up there, arc MP. So in a circle, we name parts of the circle as an arc. So just like that little line segment up there, MB, that's a line segment. We call it MB because the endpoints are M and B. In the same way, we name an arc of a circle by naming the endpoints of the arc. So that little piece of the circle there in quadrant 1 is called arc MP. And all 4 of those inscribed angles mark off the same arc. Now, in geometry, we use another word to mean mark off, and I'm not really sure why we do this, but you'll see it in your textbook, you'll see it in any other literature concerning this topic, and I will use this word. The word is subtend. So each one of those 4 inscribed angles subtends the same arc. Subtend is a word that just means mark off or delineate. So each one of those inscribed angles subtends arc MP. Now, you may have already noticed that each one of those inscribed angles has the same measure. And I'm going to move one of them around. I think I'm going to move this angle, this point C around the circle here. And it's not changing the measurement of that angle. I can move point C right up to almost right next to point M. It's still a 22-degree angle. That's kind of interesting. So one of the first points here, and I can move other points around the circle as well, and the same thing happens. None of the angles is going to change their measure just because I move them around. So what this tells us is that any inscribed angle that marks off or subtends the same arc as another inscribed angle will have the same measure. Extremely important and useful little fact about inscribed angles in a circle. The only way I can change the measure of those inscribed angles is to change the size of arc MP. If I move arc MP around, now we've got the angles changing size, and they're all changing exactly the same way. All right? So I'm going to leave arc MP just like that, and you see all 4 inscribed angles subtending that same arc and having the same measure. Okay, so now I'm going to do one more thing. I'm going to make a line segment between point M and the center of the circle, and between point P and the center of the circle. So now I've got another angle marked off there. Kind of happens to be right aligned with those other ones. Let me move this one here. Because there doesn't need to be anything. Okay, so now we've got 4 inscribed angles and a central angle there. That's what that's called there, that MAP angle. That's a central angle. Its vertex is on the center of the circle, and they are all subtending the same arc. Let's measure the central angle and see if we can see what the relationship is between the central angle and the inscribed angle subtending the same arc. Can you see that? It's 48 degrees. All right, let me see if I can move that around so you can see it a little bit better. There we go, 48 degrees. So look at that. The inscribed angles are 24, and the central angle is 48. Is that just a coincidence that the central angle is twice as big? Let's try to move one of these points around and see what happens. I'm going to move point P down here so that it's a 90, let's see, I want to keep it an even number just because, come on, even number. How about right there, 74 degrees. What's half of 74? Yeah, it's 37. So every time I move one of these arc endpoints, all right, the central angle changes, all 4 of the inscribed angles changes, but what doesn't change is the relationship between their measurements. The central angle is always twice as big as the inscribed angle that subtends the same arc. Very, very useful concept about the angles in a circle. All right, so that's what this video was all about. I would like to just kind of summarize that with some verbiage. Hopefully you can replay the video if you want, but here's the basic facts that I wanted you to pick up here in this video. An inscribed angle has its vertex on the circle, so you need to know what that's called. And it subtends or marks off an arc or a portion of the circle. So that word subtend is going to be used. Just kind of keep that in your vocabulary there. An angle subtends an arc. That's how it works. Any inscribed angle that subtends the same arc will have the same measure. And then the third point, extremely important point here, is that a central angle has its vertex at the center of the circle, and if it subtends the same arc as an inscribed angle, its measure will be twice that of the inscribed angle. All right, so hope you enjoyed that. Thanks for watching. Bye.